In this example, I'm going to show you how to convert an ordinary number into floating point format. And this looks quite daunting, really. 40.15625. I'm going to convert that to a floating point number using a mantissa and an exponent. Okay, here we go. Let's deal with the 40 first. I'm going to use 8 bits to represent 40. And those 8 bits to represent 40 are going to look something like this. I don't need 128, I don't need 64, I will use 32, don't need 16, but I'll use 8, 32 add 8 is 40, so I've got that. So the rest of the bits in my byte here are going to be 0, right? So that's the 40. So that leaves me with the 0.15625. Now, watch the method to get the bits for the mantissa here, okay? Because what you do is you take that decimal part and you multiply it by 2. Now, if I multiply that by 2, I get 0.3125. Now, let's think about what we've got here. That number isn't bigger than 1. So what I'm going to do is just record a 0 here. And what I need is the answer. If the answer is bigger than 1, I'm going to record a 1. If it's not, I'm going to record a 0. But let's take what we've got now. 0.3125. And let's multiply that by 2. And let's see what we get this time. Well, this time we get 0.625. Now, if you notice here, the number is still less than 1. So what am I going to record? That's right, a 0. Okay, let's write down what we've got. We've got now 0.625. I'm going to do the same again. Why am I timesing by 2? Well, it's a binary system, isn't it? It's a two-state system. So we use 2 a lot. Let's see, what do we get this time? 1.25. Now this time, the number is greater than 1, so I'm going to mark a 1 here. Let's take the decimal part of what's left there, right, which is the 0.25. Yeah, you don't put 1.25 down, you take the decimal part, and that's 0.25. I'm going to times that by 2, and what do I get? Well, quarter times 2 is a half, that's 0.5. That's not bigger than 1, so I'm going to record a 0. I'm going to take the 0.5, and I'm going to multiply that by 2. What do I get this time? Well, I get a 1. Okay. Well, it's equal to 1, it's bigger than 1. What I'm going to do at the side here is record a 1. But the key thing is, when you get to 1 there, what you do is you stop. So this process is stopped. So 40.15625 as a number in floating point format, and it could look like this. Let's just write down what the 40 was. It was 0, 0, 1, 0, 1, 0, 0, 0. If I put a binary point in here, the number that I wrote down in my working out was 0, and then I add a 0, then a 1, then a 0, and then a 1. Alright? So I've got my fractional part there. Now what I need to do is normalize this. Okay? I need to normalize this. And what I'm going to do, let's just change the colour of my pen here so you can see clearly what I'm doing. What I'm going to do is I'm going to say, well, okay, look, to normalise this number, I know it's a positive number because it's 40, so I want my binary point to really be here. Okay? So if that binary point is going to move that way, that's 1, 2, 3, 4, 5, that's 6 jumps. Okay? So that tells me something about the value of my exponent. The exponent as a value is going to have to equal 6. So my normalized number when I finish this, I'm going to be left with this: 0, 1, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1. That'll be my mantissa. Remember that the first digit there is my sine bit. Right? This is all part of my mantissa. Okay, let's label that mantissa. And then I've got my exponent. Well, my exponent's going to be 6. It's a positive value, so I'll just use 3 bits for that. 4 plus 2, 1 and 1 is 6, so if I have a 0 there, that is my exponent. So that's the normalised form of the floating point number that represents 40.15625. Use the worksheet on the Moodle Learning Resource Centre and have a go at some of the questions for yourself.